The the paper is open for discussion, so if you people have questions, please raise your hand, and Professor Painter will take the questions. Yes.
Question is to Dr. Venkat.
Mic on, please.
Is it working now? Is it working?
Yes.
My question is to Dr. Craig Winter. So with due respect to you, you've always been considered a controversial scientist, a biologist, because of the recent synthetic bacteria discovery also. How does it feel after having achieved so much and done so much for the scientific field? How does it feel to have been called controversial?
It seems to be a favorite phase of newspapers, so it's interesting we're having this with a news session. That's the first question. If you're not at the leading edge of your field, you can't make progress, and if you're making real progress, it will be controversial because we're making breakthroughs, understanding life at levels that were unimaginable even 10 years ago for most of us. These are major concepts. They change our view of maybe origins of life, what is life. It's bound to affect people's thinking. So the more I see it, the prouder I am of the label.
Yes.
Thank you very much for the very riveting presentation. My questions are to Craig, and the first one is, how can you be sure that the diploid genome sequence from 2007 is actually accurate now, and that further developments in sequencing won't show further changes?
So it's a great question in terms of no human genome sequence yet is truly complete because the sequences that are in the centromeres and telomeres are the same repetitive elements over and over again. So we don't know for sure the exact sequence of every one of those. But the exciting thing about some of the new technologies that are coming out of being driven by the X Prize and other approaches, they're based on not cloning DNA, so we have less artifacts with it, and some of these techniques work better with repeats, some work not as well. So every new technique that's being done is building on the reference sequence that we published already. So the accuracy will only get higher and higher over time. But it's a big difference because what was done in 2001 were composites, and they were only half of the genome as a composite, so it gave us very misleading views. In terms of knowledge from the genome, the world will be making major discoveries from the human genome 100 years from now. So we're at the earliest stages.
Sorry, and my second question is, I was very interested with your preliminary comments when you said that you were hoping that sequencing would give more information about the phenotypes of humans. And obviously, that can be very difficult to characterize or diagnose even clinically. For example, behavioral disorders or the difference between schizophrenia and bipolar depression, where it's difficult as a physician to even diagnose. So how do you hope to do that genotypically when even phenotypically it's difficult to know what you're looking at?
That's another great question. So in fact, that's one of the biggest challenges of modern genetics, is to do accurate phenotypic characterization. But as you indicated, it's a problem of modern medicine. In the U.S., even though there's standards of care that are established, the indications are less than half the physicians follow those standards of care. So universal diagnostics and understanding things is very difficult. So in the early stages, in addition to accurate sequence, we need well-characterized phenotypic bits of information that can be digitized. So we're talking to groups around the world that are specialists in different areas to help put together criteria of that particular area to help set a world standard for what should be done for collecting phenotype information. But it's a huge challenge. When I think of all the things that characterize my own life, I tried to write an autobiography, and that was difficult. But if you try and think about all the aspects chemically, physically, medically, it makes sequencing the human genome seem very easy.
Thank you very much. Thank you.
Just to add on this, this is where Indian patient pool, because you need large data set, well-characterized phenotype to match with the sequence. So this is where it becomes very critical. So once you have those markers, which are significant associated with bipolar, depression, manic depression, schizophrenia, then actually Indian patient pool becomes very critical. And that's where the linking will be required. And you need endogamous, clear phenotype. So that's the challenge of the next 10 years. Yes.
Dr. Venkat, these exciting discoveries, I think one of the main aims would be to have a better human race, a superior human race. Now, what is the kind of time frames which you feel would be there where we can have better children in terms of intelligence, in terms of health, etc., so we don't pass on our diseases, if I may say, to them and so on. What is your idea about that?
Well, fortunately, the human race keeps getting better by changes in society standards. But when we look at our history as a species, it's not so glorious. But when we look at most of modern society, some of our barbaric tendencies seem to disappear, either by rule or by standard acceptable behavior. I think following on the previous question, we can't even characterize well the phenotypes of individuals. I've not met a human yet that I thought should be cloned. So I think trying to define characteristics that we'd want to alter genetically, it won't happen and shouldn't happen this century. It will happen sometime in the distant future. I hope we'll wait till we have sufficient knowledge to do it truly intelligently, if that's possible.
And also, if you eliminate schizophrenia and things like that, you will lose the beautiful mind. So you'll also lose genius. Yes, back.
My name's Ian Buller. My question is on the energy potential.
I can't hear you.
Oh, sorry. Can you hear me now?
Yeah, louder.
My question is on the energy potential of your work. I think there's a sort of a risk of complacency here when people think that that fossil fuels will be replaced. They may reduce their efforts to reduce energy use. So my question is, how long could it be before this potential for energy production is reached? And will it be able to meet a significant proportion of our energy needs?
So they're both good questions, and the implication is we shouldn't talk about potential breakthroughs if it doesn't lead to changing people's behavior. I've advocated that we need every type of breakthrough we have in every field of science and engineering. Biology will provide part of the solution. It's not clear how big of a portion, but we need thousands of parallel solutions in addition to learning how to conserve energy better. But I think some of these ideas are on they're years, not decades away. But the challenge is what your second question really implies, and the scale. And the scale is daunting. It's actually mind-boggling. When we think of trying to produce fuel, and imagine one reactor, a bioreactor that could make 20,000 liters a day. That seems like a very reasonable size reactor. But we need 1 million of those right now to replace what we're using daily in terms of fuel. It's the most insane number that sort of has crept up on human civilization. And it's hard, even though I deal with large numbers all the time, to truly appreciate the scale that we use fuel that we burn carbon and put it in our atmosphere. That's why the air here is not so clean, why it's a problem everywhere. And so one of the notions that we're trying to develop is maybe going back to things that Edison advocated of generating power locally and using it locally instead of generating it in a few centers and piping or transmitting it long distances. So if you imagine 300,000 mini reactors in India using a variety of feedstocks, whether it's the abundance of sunlight here, plant feedstocks, etc., it's not hard to imagine being able to get to the scale to change things. But in the U.S. now, there's about 160 corn to ethanol plants. They produce 6 billion gallons of ethanol a year. That has only a 2% effect on fuel consumption. So the scale is daunting to everybody.
Yes, madam.
Dr. Venter, you have sequenced your genome and your DNA, I read somewhere. Did you find something extraordinarily different or unique that makes you what you are, as brilliant as you are?
I wish I could say yes and thank you. Well, it's hard to tell, seeing that there's only one human that's been completely sequenced. But Jim Watson has now had his genome mostly sequenced. It has not yet been published in the scientific literature yet. But we hope to see an exponential change in the numbers of humans that have their genome sequenced so we can do comparisons. But I think if you look at, I guess I'll make a plug for my book, Life Decoded, my autobiography, you'll see that it was mostly environmental interactions that I've had throughout my life that's probably resulted in the directions I've gone in. I started with some pretty good parents, though.
Yeah, maybe Vietnam War had more effect than the genetic variation. I think we'll take some mail by Allah is there. You have to tell me when I have to close.
Hi, good morning, Dr. Venter. My name is Varun Chaudhary. I'm from New Delhi. I have a very basic question. As all of us know that in our ecosystem there exists a balance, a harmony, what we call as the ecological balance. Whenever we try and play around with this, there is this harmony which is caused, or which we call as the imbalance. For example, if we are burning coal, we are generating CO2, which causes global warming. Now my question is, when you talk about genetic engineering or synthesizing genomes or creating them artificially, will it have a negative impact on the environment? Will it produce some sort of a waste or something which causes disharmony or imbalance in the ecological system? I hope you've got what I'm trying to say.
No, it's a very good question. In fact, the problem is right now we have an organism called humans, that there's 6.5 billion of us. Within 40 years, there'll be 9 billion of us or so. I was born in 1946. There's now 3 people alive on this planet for everybody that existed the year I was born. In 40 years, there'll be 4. We're causing a tremendous ecological imbalance. We've taken 99% of the species out of the oceans. We're creating massive extinctions. So I think it's a little foolhardy to talk about existing ecosystems as though they're in balance, because we're rapidly destroying all of our ecosystems. Our goal is twofold. It's to try and provide an alternative for taking the carbon out of the ground and adding it more to the atmosphere, causing further disruption. But nobody is advocating releasing any organisms into the environment. As with the DuPont organism, these would be used in closed cycles. There's been now a 30-year history of molecular biology experiments with E. coli that's been modified so it can't grow outside of the laboratory. My estimation is at least 10 million experiments. You may have a different number, never with an issue or change in the environment. We know enough about biology to design organisms so they can't live outside a defined chemical system. In fact, if you looked at the slide on designing species, we have extra fail-safe mechanisms such as suicide genes to build into organisms. So we hear quite frequently from people that we may take too much CO2 out of the atmosphere. I totally hope that's an issue we have to face.
I'll just have a request to close, so I'll just the last lady, please.
Hi.
I'm sorry, I have an instruction to close after this.
Does creating synthetic biological systems suggest there's no soul?
There's no soul.
I don't know too many people who have advocated bacteria having souls. You know, there's.
So, where this research is going?
Well, it's important to truly understand life. So obviously, simple life forms are the equivalent of molecular machinery, and we can define those. When we look whether it's a complex ecosystem where we have thousands of different organisms working together to create one unique environment, or a multicellular organism like ourselves with 100 trillion cells, as was said in the introduction, I view that the outcome is far greater than the sum of the parts. So we're not just simple mechanical systems. Humans are the most plastic species on the planet. We're designed or evolved to respond dramatically to our environment. Whether people want to attach religious significance to some of these characteristics or not is of individual choice.
As we close this session, which is the DNA of the future, we might take back home that in the evolutionary scale, the nature evolved to create a species called human. And once human is created, with 3 times larger the brain of the chimpanzee, then I think evolution is taken over. And one of the special person just having with us, who is accelerating the evolution. Thank you, Craig, to be with us. We're here. Thank the India Today Enclave. Thank Arun Puri for providing us this opportunity, and thank you for all the audience. Thanks.
May I request Mr. Puri to please come up and present Dr. Craig Venter. Thank you very much. This was a really interesting discussion, Dr. Venter and Professor Brahmachari.